Okay, this is page 3 of the shadow test. Question 21 is another question about standard form, but it's asking us to do a calculation with two numbers that are in standard form, and it's an addition. Now I'll show you the way I like to do these. Notice that this power is 1 bigger than this power. So if I were to line these numbers up, this first one would be 7 and a 9, and then I need to move the decimal point 5 times. So 1, 2, 3, 4, 5. So I'm going to add in 4 zeros. I'm adding 6 times 10 to the power of 4. Now I know the 6 is going to go there. How do I know that? Because it has 1 less in its power of 10. So I know it's going to be a factor of 10 smaller, therefore in the next column of the place value. Okay, so just to show that I'm right there, I need to move the decimal point 4 times. 1, 2, 3, 4. You can see this is going to have 4 zeros. So when I add them together, these are all going to be zeros. 9 add 6 is 15. Carry the 1. That makes 8. Okay, it wants us to give our answer in standard form. So the answer is 8.5 times 10 to the power of 5. Oops. Okay, now we could have just said 7.9 and we're going to add 6 and we're going to put that at the end of it. Okay, and that would have worked as well. Only because this power is 1 less than this power. Well, in question 22, we are dividing two numbers in standard form. And I always like to look at this as a fraction first. So 2.4 times 10 to the power of 6 divided by 6 times 10 to the power of 3. And the easiest way I find of doing this is to do them in parts. Do this division, and then don't do this division, but just simplify this division. Okay, so let's start with the 2.4 divided by 6. Well, 24 divided by 6 is 4, so 2.4 divided by 6 is 0.4. And what can we do with the powers when we are dividing two numbers with the same base? Some of you remember we can take them away, so this would give us 10 to the power of 3. Now that looks like a number in standard form, but it's not quite. The problem is this number here is not between 1 and 10. So to turn it into a number between 1 and 10, I'm going to turn it into a 4. I've times it by 10. So I need to divide this bit by 10. And dividing 10 cubed by 10 would just give me 10 squared. So the answer is 4 times 10 squared. Okay, number 23. Just a question asking us to do some rounding. They've done the calculation already, so they want us to round this to two significant figures. Well, the first 3 is the first significant figure, it's the most important figure there. The 0 then does count as the second significant figure because it follows a number. So should that stay a 0 or should it round up to a 1? If we look at the next number along, it's a 3, it's less than a 5, so this is going to stay as a 0. So we're going to keep those first two significant figures as 3, 0, but they have to stay where they are as well. So I have to fill up the other places with zeros. They're just placeholder zeros. So the answer is 30,000. To one significant figure, what we're asking is just looking at this first one. We're saying, should that stay a 3 or should it round up to a 4? Well, we look at the next number to help us decide. It's a 0, so this is going to stay a 3, and everything else will be a 0. So actually we end up with the same answer. Number 24. Same style of question, just a decimal number, this time rounding to two significant figures. The first significant figure is the 7. Second significant figure is the 1. So should that stay a 1 or should it increase to a 2? It should round up to a 2 because the next figure is a 7, which is higher than a 4. So this is going to be 7, 2. But those digits need to stay where they are. So we need some placeholder zeros to the left. So 0.072 is the answer. Estimation questions. A good rule of thumb is to round to one significant figure. Round every number to one significant figure. So this is approximately equal to Right, let's start with this number, 316. The first significant figure is 3. Should it stay a 3? Yes, if we look, the next digit is a 1. So this is going to be 300. On this number, the first significant figure is a 5, but should it stay a 5? If you look at the next number along, it's an 8. So this is going to round up to a 6. It's going to be 600. And then when we're dividing, the first significant figure here is a 1. Should it stay a 1 or round up? Well, the 9 next door tells us it's going to round up to a 2. Again, it needs to stay where it is. Okay, so we've got an approximate calculation now. I'm going to work this out. Timesing anything with zeros in and dividing with zeros is easy. That's why we use this method. So 3 times 6 is 18. And then we've got 1, 2, 3, 4 zeros we're going to put on. Divided by 200. Now when you're dividing two numbers that both have zeros, they're both multiples of hundreds, in other words, we can cancel off those shared zeros. So this is 1800 divided by 2, so 900. Okay, number 26. Related calculations. So using the information that 3.8 times 42 is 159.6, write down the value of this. So on this question, this number has changed. It was 3.8, now it's 38. So it's got 10 times bigger. So it is what we had at the start times 10. And the 42 has stayed unchanged. So that's what we've done to the left-hand side. Therefore, that is what we also have to do to the right-hand side. And you can see, that would give us 1590. Okay, on B, 380 is 3.8 times 100. 4.2 is 42 divided by 10. So those are the things we're going to have to do to the right hand side as well. We're going to have to times by 100 and then divide by 10. So when I times this by 100 it becomes 15960, and then when I divide by 10 I will just lose that 0. The answer is 1596. On a division question like C, if I was to rearrange the original, looking at this division, that would imply that I can times 38 by something and get 1596. This something, this question mark that I put here, is going to have the digits 4 and 2 in it. It's just a case of where the decimal point's going to go. Well, 38 is 3.8 times 10, so that number's got 10 times bigger, so has the answer. Okay, so actually this one doesn't need to change at all. If we treat this like one of the either question A or question B, the first number in the question has got 10 times bigger than 3.8. The second number doesn't need to change. It's going to stay as 42. The answer effect is that it will get 10 times bigger. So the answer is 42, and you can check that roughly by estimating. 38 is close to 40. 42 is also close to 40. 40 times 40 would give us 1600, this is very close to. Number 27. Simplify the following. So when we're timesing together the same base, we can add the powers. Just watch out for this one. It does have a power of 1 there. So this will be 4 to the power of 8. On question B, we're going to add the powers in the top row first. That will give us 6 to the power of 7. There is a 1 there. Look out for that one. That will give us 6 to the power of 3. And then when we're dividing numbers with the same base, we subtract the powers, so 6 to the power of 4. And on part C, when we've got brackets and the powers either side of the bracket, we can times the powers together to simplify, so this would be 3 to the power of 9. On number 28, anything to the power of 0 is 1. And on number 29, That looks really hard, but the whole thing is just to the power of 0, and I've just said anything to the power of 0 is 1, so the answer to that is 1.